In this video, I introduce Wave2vec version 2.0 self-supervised pretraining for speech representations. Self-supervised pretraining learns general data representations from unlabeled examples and then fine-tunes the model on labeled examples for downstream applications. Wave2vec 2.0 is a framework for self-supervised pretraining of speech representations from raw audio signals. Wave2vec 2.0 encodes speech audio via a convolutional neural network and then masks the spans of the resulting latent representations. The latent representations are fed to a transformer decoder to reconstruct contextualized representations. Wave2vec 2.0 model is trained via contrastive task where the true latent representations are to be distinguished from distractors. This is the Wave2vec model. This is the input signal. This encoder and this transformer decoder. Contrastive loss is used to minimize the loss between prediction and the target. Feature encoder is a temporal convolutional neural network. The decoder is a transformer architecture. Mask operation is on latent representations Z instead of input X, namely we put a mask here, not on the input signal. Gumball softmax is used to compute the gradient in the backward path. This architecture of Wave2vec 2.0 model. This input and this feature encoder and this transformer decoder. Contrastive loss is used to minimize the difference between CT and QT. This is the code book. We use W maps the CT to QT. And we use matrix M maps ZT to projection L, which is used to calculate the Gumball softmax. In the forward path, we use this maximum P. And in the backward path, we use this Gumball softmax to calculate the gradient. Wave2vec 2.0 masks a certain proportion of time steps in latent representation. The training objective requires identifying the correct quantized latent audio representation in a set of distractor for each masked time step. The total contrastive loss L consists of contrastive loss LM and codebook diversity loss LD, as shown here, where alpha is a toned hyperparameter. The contrastive loss LM measures the loss of the prediction CT from the true quantized latent speech representation in QT, as shown here, where K is temperature parameter. The diversity loss LD is used to increase the use of the quantized codebook representations, as shown here, which encourages the model to equally use the V interested in each of the G codebooks. For more details, please check with these references. Thank you. Bye.